Hi guys, sorry I couldn't be there today, but we have to get through some of our notes, just like if I were there. So I'm going to go through notes via video. You should already have this packet in front of you, exploration number 3. But if you don't, make sure you grab it before we get started. And I'm going to go through notes just like I normally would, and you're going to take notes just like you normally would. Stopping for practice problems, making sure that you have everything written down I have written down, all of those kinds of things. When I return, we're not going to go through this again. We're just going to have practice time on it, assuming we already learned it. If you have questions and those kinds of things, you can ask when I get back. But otherwise, let's get started. So the first thing we're going to talk about is this first think section. So please pause the video for 3 minutes. During this time, everyone should be attempting to write an equation for this scenario or solve this scenario with your group or alone. Pause the video for 3 minutes. Alright, you had your time to think about this, so I'm going to go through it. It says the posted weight limit for a covered wooden bridge in Pennsylvania is 6,000 pounds. A delivery truck that is carrying X identical boxes, each weighing 14 pounds, will pass over the bridge. If the combined weight of the empty delivery truck and its driver is 4,500 pounds, what is the maximum possible value for X that will keep the combined weight of the truck, driver, and boxes below the bridge's posted weight limit? So there's a lot of information in here. But basically it's asking how many boxes can we put into this truck. And so we have kind of a starting weight of things we already know. Remember we talked about the other day, a good tip would be to go through and underline everything we think is important. So the weight limit is 6,000 pounds. That's probably pretty important. We have each box weighing 14 pounds, and the weight of the empty truck and its driver is 4,500 pounds. So those are some pretty, that's pretty helpful information for us. Let's see if we can use that information to start writing an equation or solving an equation. So what I would do is I would think about, well, how much weight do I have left after we've factor in the truck and its driver. And so if I was just kind of reasoning through this, I would take my 6,000 and I would subtract my 4,500, and that'll tell me like how much extra weight I can use for boxes. So 6,000 minus 4,500 gives me 1,500, and that's what I have left. Then it says it has each box weighs 14 pounds. So I can just write a very quick equation. 14x equals 1,500. And then I can solve that equation, divide by 14, and I get x equals 107.14. Well, this doesn't really make much sense in terms of the context because it's asking us how many of these boxes can I bring to not go over the weight limit, and I can't bring 107.14 boxes on the truck. So the maximum amount that I could bring to not go over would be 107 boxes. So this is kind of my quick way of reasoning through it. The other equation that I think a lot of people would have written is if we start with 4,500, that means that's our starting weight, and we add 14 pounds per box, that needs to equal 6,000. And if you solve this blue equation, you actually end up doing the exact same math that I did when I was just reasoning through it before I was really writing an equation. You end up subtracting the 4,500 from 6,000 and simplifying it to what we had in red. And so if you wrote this equation, that's a really good equation to have as well. So let's move on to the next section. So we have another think section. In this one, it's talking about the sale of a car. And I'm actually going to go through this one just like notes. Normally we'd have some time to work on this as a group, but I want to go through a problem in its entirety, just kind of like notes. So make sure you're following along with all of this and writing down all the steps that I write. Problem says the tax on the sale of a car in Michigan is 6%. At a dealership in Ann Arbor, population 121,500, a car purchase also involves $120 in miscellaneous charges, including a $37 service fee paid to the state and a $13 title fee, among other charges. There are several quantities in this situation: the original car price, sales tax, miscellaneous charges, and total price. Write an equation to describe the relationship between all the quantities when, and then it gives you a couple situations. So let's start with part A. It says the original car price is $9,500. So the first thing I want to do is I want to go through and I want to underline the things that I think I'm going to use from the story. So I kind of have, there's a lot of numbers in there, a lot of information. So I want to go through and highlight the things I think are important. The first thing I think is important is it says the tax on the sale of a car is 6%. Then it says the population of Ann Arbor is 121,500. The population is not really important for purchasing a car. That's just giving you some context into what the city of Ann Arbor is like. So that part's not important. I'm not going to underline it. The next part I see is that it says a car purchase also involves $120 in miscellaneous charges. So the other charges we're going to need to underline because those are included. And then it kind of breaks down those charges. So the keyword is including. That means that those fees are included in the $120. So the $37 service fee and the $13 title fee are actually not important in and of themselves because they're already wrapped up into the $120. And so that I'm also not going to underline because it's already included in the $120. Once I use it once, I don't want to use it again. So then it gives us part A, which was the original car price. And so we want to write an equation about what I'm going to be charged if I go and I buy a car that's $9,500. And so the first thing is we want to look at the tax part of it. We know that we get taxed on our total amount. So I'm actually going to need to take the original car price and add in any fees before we do the tax. And so the original car price is $9,500. And then I'm going to add that $120 fee. And then if I need to do this before I do tax, remember we want to make that group together by using parentheses. So that I want to put parentheses around that part so that that happens first. And then tax is super interesting. So when we have a percent of something, when I'm taking a percent of something, you can kind of do it two ways. The easiest way is we're going to pay for 100% of this plus 6% of it. And so you kind of have to take 106% and turn that into a decimal. And so I'm paying for the tax 106%. That turns into the decimal. You just move the decimal over 2 spaces to 1.06. So that's it as a decimal. And that's what I want to multiply by. And we know that numbers usually go out front of parentheses. So I'm going to put 1.06 out in front. The other way you could do this is you could do this math kind of twice. You find your total. You know you're obviously going to be paying that. You find 6% of that total, and then you add those two values together. This is the much easier way to do tax. So if you are ever doing tax on something, make it 100 plus that number, and then turn that into a decimal. And so this is going to equal my total. And remember, whenever I use a variable, I want to define that variable. So T is total cost. And so I could do that math, but it didn't ask us to. It just asked us to write an equation. So I'm going to move on to part B. So part B says that the total price is $22,480. So now instead of knowing the original price, I know the total. And so I can kind of use my equation I just wrote and switch out some things. I know I'm still going to have the 1.06% tax, but now this time I don't know the original car price. So I'm going to use a C here, and I'm going to go ahead and before I continue define that that is the original car price, just so I don't forget. And I still have to add the 120, but now this time I know the total, and that's 22,480. Okay, so for part A and part B, you want to just kind of take your original equation, fill in the things that you know, and then you could solve both of those equations if you wanted to. Now let's look at part C. For part C, it says the original price is P. So no longer do we have numbers for the original or the total price. So we're going to take our equation and we're going to fill in those variables. I don't have to define P because it already tells me what P is. And so I don't need to write off to the side that P is the original price because it already gives it to me. If you would like to write it, that's fine as well. But let's write our equation. So we have our 1.06. Our original price is P plus the $120 fees, and that should equal our total. We already defined that variable above, so I don't need to define that one again. This is really what the bare bones of the equation would look like. If you're trying to figure it out, the sales tax is not going to change. The fees are not going to change, but what will change is the relationship between the original price and the total price. So this I could plug in any value, whatever one I know, and I could figure out the other one. And then part 2 says, how would each equation you wrote change if the tax on car sales is R% and the miscellaneous charges are M dollars? So this one is assuming, okay, we've left Michigan, the sales tax is a different rate, and the charges are different. So what are we going to do for that? And so remember when I changed the 6% to a decimal, I did 100 plus that value and then move the decimal 2 places. So we're going to do the same thing, but we're going to write that out in the equation so someone else could do it. So we're going to do 100 plus R. And then to move the decimal places 2 spots, all we're really doing is we're taking it and we're dividing by 100. We're taking 2 decimal places off of it. And that would change whatever percent you have, like let's say it's 13%, and it would change it to 1.13. Okay, so we're gonna, that's how to change that to a percent. Then we have the original car price, P, plus miscellaneous charges, M, and that will equal our total. So now we have a super generic equation that we could use for any state. Any time the sales tax changes or the fees change, we can kind of update this as we go. So a couple things I want to write down in this meaningful notes section. First, I want to talk about percentages because that's something that's going to come up and we need to be able to change. So to change a percent to a decimal, we divide by 100. So you take whatever your percent is and divide by 100. If the percent you want is a tax, you want to add it to 100 before dividing. So if it's going to be a tax or something where you want to take the whole plus an additional piece, then you want to add it to 100 before dividing. So the last thing I want to write is to, in all caps, write this. Beware of miscellaneous information. Some things won't matter. So the Ann Arbor population didn't matter. The charges that they described don't matter because it was already included. So keep that in mind as well. Finish copying these notes. We're going to get started with part 2.